So you have an integral and you've tried pretty much everything and you cannot solve it. Now what's special about your integral is that it is in the form of a fraction. So it's not anything but a fraction. And you've tried your algebra, you've tried your u sub, nothing's working. And you can actually go ahead and I encourage you to actually go ahead, try your algebra, your u sub, and your by parts maybe even. Go ahead, try those and try and solve this one out. And what you'll realize is that this one is not actually going to solve. So this one is actually a different kind of integral, and there's a different way of solving this. And well, I've written two tips over here to help you spot these sort of integrals. And the first tip is that if you basically have a fraction in your integral and it's not solving, then there's a high chance that that fraction is actually a partial fraction. And also, this other tip, this is really helpful. Though it's not necessary, you won't always this tip won't always be true. But the idea is that a lot of times the denominator will consist of bracketed terms, and you can see there's brackets over here, there's brackets over here, there's terms inside the brackets. So the denominator is going to have terms that are in brackets, or in other words, they're factorized. You can multiply these brackets and open them and expand them, but right now these brackets are factorized. So these two tips, these are the main tips that will help you identify partial fraction questions. And actually, I'm just going to go over here and I'm going to show you some of these partial fraction integrals. Let's say this was an integral and all of these were integrals. You can see they kind of look the same. They're all fractions and they all have these sort of these brackets that, you know, they hint to you that this is a partial fraction question. However, this one over here is a weird looking question, and I'll get on to the ones that I've tagged with the yellow marker. I'll get on these in a bit. But first of all, let's go over here and try and solve this partial fraction question. So we have this fraction. We already know it's a partial fraction question. So what do? Well, you just go ahead and you apply the partial fraction on this part, this integrand, this thing that you have inside. You apply partial fraction on it and you'll basically get something that looks like this. So it's going to be x plus 1. I'm not going to do the partial fraction for you guys because that's a different topic, but I hope you know how to do partial fractions. So this is going to be x plus 1, x minus 2, and it's going to be 1 plus 2. And so basically this thing right over here is equal to this entire thing down here. And so this is what we're essentially now going to have in our integral. This is going to be 4, 3, 1 over x plus 1, and then we're going to have 2 over x minus 2 dx. Now this already looks a lot simpler, and you can already go ahead and apply a lot of tricks on this, a lot of techniques on this to make this simpler. The first thing I would want you guys to do is kind of realize that it's a plus sign over here, so you can kind of break this down into two integrals, and that's what I'm going to do. So I'm going to basically break this down into two pieces. It's going to be 1 over x plus 1 dx, and it's going to be 2 over x minus 2 dx, right? Now you can actually go ahead and realize that if you do go ahead and take these denominators into the numerators, it's actually going to give you a beneficial result, or it's actually going to give you something that you can use to simplify your integrals further. And let's see what that's going to look like. So I'm not going to write the limits for a second. I'm not going to write the 4 and 3. I'm just going to say you take the x plus 1 to the numerator. It's basically going to become x plus 1 negative 1 dx. And then you have your 2x minus 2 negative 1 dx. Right? You can already see the 2 over there is a coefficient, or it's a constant. You can pop that outside the bracket. So I'm just going to do that over here. So that's a 2 over there. Now, what does this look like? It's still not a simple integral. It's clearly not a simple integral. But when you look at this thing, it's kind of really simple it's kind of really obvious to realize that, okay, I can apply u sub on this. I can go ahead and make that thing my u, and I can go ahead make that thing my u, and then and that thing is going to become obviously du. That thing will become du, and I will basically have u to the power minus 1 over here, as well as u to the power minus 1 over here. And what's that going to be? That's just going to be ln. Okay, so that's going to be ln this thing, and then it's going to be ln x plus 1. It's going to be ln x minus 2, right? When you do u sub, it'll make sense. I'm not doing the u sub over here, but it's going, you apply ln and it's going to solve for you. And then you can apply the limits, the 4 and 3 at the end. But that's basically the idea over here. So the main thing was you had this weird looking integral, and it was not solving. So the trick was that you had to realize that, okay, it's a fraction. Okay, that's a huge indicator. It's a fraction and it's not solving with any other technique. The other thing that you can realize is that the denominator consists of bracketed or factorized terms. That's not always going to be the case, but most of the times it will be the case. And so you have to apply partial fractions to simplify this thing over here. And now if I go over here, what I want you guys to notice is that these cases that I've highlighted in yellow, I've tagged with the yellow marker. Something about these cases is that for these cases, what you'll realize is that this is an x to the power 3, right? And then this is the highest term, which is x to the power 2. Now when you expand this denominator, obviously this is going to go and multiply with that. So the overall highest term in the denominator is going to be x to the power 3, and that is the same as that term over there. And therefore this is an improper fraction. So what happens when you have an improper fraction? Remember, you cannot apply partial on an improper fraction. Partial fractions do not work on this. So you have to first do long division, right? You have to do long division. Synthetic division doesn't work. Then you convert this thing into a proper fraction, and only then can you go ahead and apply partial on it, right? That's the workflow over here. So you go at this thing right over here at the bottom. You see the highest term is x to the power 2. Over here you don't have factorized terms. You don't have terms in the brackets. But what you can see is that you have that x squared term over there. So the highest term in the numerator is the same as the highest term in the denominator. So this is clearly an improper fraction. So you do long division on this, get rid of that x squared in the numerator, okay? And then when it's a proper fraction, only then can you apply a partial fraction on this. And so you can see the same over here. This is an x squared, that's the highest term. There's an x term over here, there's an x term over here. Of course, they're in brackets, so when you expand this x is going to get multiplied to that x. The highest term you're going to get is x squared. And so then again, you're going to have to do long division for this one as well. All of these other examples that I have, they have a smaller degree in the numerator. For example, if you look at this example over here, this has an x to the power 1, whereas this denominator term, this x is going to get squared, then it's going to be multiplied with that x, so the highest degree term is going to be x to the power 3. So you don't have to do a long division for all of these other terms, but you do have to do them for this example, and this example. So that's what you're trying to do. And remember, partial fractions have a really specific kind of look. If you look at all of these examples, they all have factorized or bracketed denominators. You can see all of them sort of have brackets except for this bad boy right over here. But again, it's a fraction. It won't solve by any other method. You can go ahead, try it out. It already looks like a huge fraction, so that's already an indicator that it's a partial fraction problem. And what I want you guys to do is I want you guys to practice on these partial fraction problems. I want you guys to apply the partial fraction or long division on these problems and then integrate them. And you don't need limits. You can go ahead and integrate them with a indefinite integral. So try that out and use ChatGPT for answers.